This is the screencast for section 6.2, example 5, using substitution. So we're going to use substitution again. As you can see, I have the antiderivative of x squared times the square root of a function. So this is definitely a composition function. And if I look at the inside, 5 plus 2x cubed, the derivative would have an x squared in it. That'd be the only variable. And that x squared is on the outside. So the inside and the outside are related by a derivative. So I am going to go ahead and attempt substitution, plus the directions tell me to do that. So I'm going to make the u in u substitution equal to the inside of the square root, 5 plus 2x cubed, which that means du dx is going to be 6x squared, and then dx is going to equal du over 6x squared. So now I can substitute everything that I just created into the problem. So I have the antiderivative of x squared is going to stay the same, but now I have the square root of, I'm calling the inside u, and then dx is du over 6x squared. Alright, so now let's simplify. The x squared here is in the denominator, but here is in the numerator, so that's good. The 1/6, because 6 is in the denominator, can go on the outside, and then antiderivative square root u du. So that's u to the 1/2. So I can take the antiderivative of u to the 1/2 all on my own, and then simplifying the fraction and plugging in my expression back into u, I get 1/9 times the quantity 5 plus 2x cubed to the 3/2, and then plus c. Because remember, u was being raised to the 3/2, so 5 plus 2x cubed also had to be raised to the 3/2. Now I am going to verify this by taking the derivative of what I got and hoping it turns out to be the integrand. And I do that over here. It does involve the chain rule and some simplification, but I do end up, after I take the derivative of the antiderivative I got, I end up with the integrand, so I know I did this right. The now try problem number 27 says use substitution to evaluate the integral. Okay, so inside I definitely have a composition function, square root of tangent x. So the outside function is square root, the inside is tangent x. The derivative of tangent is secant squared, so I think I can use substitution because the inside of the composition and something outside are related by a derivative. So I'm going to call u tangent of x, the inside of the composition. And then I'm going to say that du dx is secant squared of x, the derivative. That means that du over secant squared of x is dx. And now I can substitute those back in. So inside the square root, I don't use tangent anymore. I'm going to use u. And then I still have secant squared x. And then dx is du over secant squared x. So that's nice, those secant squareds go away. Yay! And really all I'm doing is integrating u to the 1/2, just like I did last time, I guess. And that would be 2/3 u to the 3/2, and then of course plus c. Now I need to put the expression back in for u. 2/3 tangent of x to the 3/2, because u was being raised to the 3/2, and then plus c. Again, the problem didn't ask me to do this, but I am going to verify, so I took the derivative, and I did get, using chain rule again, because that's what u substitution undoes, remember? So I did get the integrand when I took the derivative of the integral that I got.